Hello and welcome. If you are watching this on-demand session, it is probably because you may have heard about the recent announcement of Affirmed Unity Cloud Operations solution in context of the Azure for Operators announcement by Microsoft. Affirmed's Unity Cloud Operations solution, or Unity Cloud Ops in short, is the easiest way for telecommunication service providers to lay the foundation for digital transformation for next generation of infrastructure, including 5G, multi-access edge computing, and the cloud using orchestration management and automation. My name is Sanjay Mewada, and for the next 30 minutes or so, we are going to unpack today's announcements and cover all of them in some detail. We will start with a quick overview of Azure for Operators and dive into the role of orchestration, automation, DevOps, and business intelligence in enabling digital transformation. We will cover the Affirmed Unity Cloud Operations solution and look at 4 use cases of operators in EMEA and Americas, operators big and small, market leaders and innovators, using Unity Cloud Ops to deploy 5G, multi-access edge computing, and the cloud. We will focus the presentation on why traditional orchestration management and automation solutions fall short when it comes to deploying this next generation of infrastructure. And with that, let's kick off this presentation with a quick overview of Azure for Operators, as Unity Cloud Operations announcement was at the same time and in the context for Azure for Operators. Microsoft Azure brings the power of the cloud to future-proof your network, drive down costs, and open new business models and revenue streams. We have our own telco DNA. Microsoft, with the acquisition of Metaswitch and Affirm Networks, will support you to guide carrier-grade cloud, and with our developer ecosystem, you can build solutions that will empower your customers and provide you monetization opportunities. With Microsoft, you can scale instantly to meet your evolving needs, get consistent performance and scalability across the edge, hybrid, and cloud, and create new revenue streams with edge compute, IoT, 5G, and network slicing. And most importantly, you will get a trusted partner who will empower you and your business. Your customer, your service, all powered by our technology. In the next part of the presentation, let's now shift focus to how orchestration management and automation sits at the heart of this digital transformation in the broader story and umbrella under Azure for Operators. As you can see from this slide, digital transformation touches all 3 major domains and functional areas within a telecommunication service provider: the network, IT, and operations. It looks to deliver a compelling customer experience fine-tuned to enable digital interaction and customer journeys. It seeks to accelerate the service velocity, ability to design, create, test, and deploy new revenue-generating services in days instead of weeks or months. And it delivers a high level of automation, optimizing processes, people, and data to drive digital transformation at the speed of business. Orchestration management and automation sits at the heart of this digital transformation. Straddling network and IT, it enables customer and service management, correlating customer and service data, managing service heuristics, optimizing service design, and hosting the service inventory. Across network and operations, it provides key functions and attributes to run the NOC, the Network Operations Center, enabling network management and assurance, guaranteeing service quality of services, network connectivity, and monitoring network performance and optimization. The last 2 circles, IT and optimization, straddling those, it targets OpEx, drives automation, enables rapid changes and adjustment to processes through standardized templates and automated workflow, data management and optimization for smart decision-making. So why is digital transformation so challenging? Where are the shortcomings on the current orchestration and management solutions that are holding back operators from really driving towards a substantial digital transformation of their business and driving digital operations? As one would expect, the challenges are multifaceted. And as operators move to 5G, multi-access edge computing, and the cloud, some of the challenges manifest themselves even more. Let's start with the network first. Managing and optimizing complex networks. The complexity arises from multi-vendor environments. Multiple products from each vendor, compounded further in many cases by approach of best of breed of everything, It creates long service provisioning cycles. This complexity increases manifold in 5G as functions are decomposed into microservices and you have a proliferation of interface points. Monetizing use cases. Often, even when the use cases are clear, for example, for some of the new enterprise services, even tactical things such as inefficiency with legacy approach to multi-tenant management prevent operators from directly offering service to enterprises or delivering a true operator marketplace. Another example is when a business case for network and application slicing is fairly clear, but the lack of effective activation and slicing solution prevents the rapid integration of 5G services profiles to monetize all these use cases. Number three, high OpEx. When you have multiple legacy systems, when you have so many different systems across multiple tiers, adaptation of legacy O&M solutions often results in multiple O&M platform stacks, and each of them require unique systems integration, and all of that drives significant operating expense. Number four, lack of service velocity. Automation of change management still requires, in most operators, significant manual intervention and tremendously hinders the service velocity. DevOps, all the way from software to people, moves it beyond the classic siloed structure and becomes a key requirement. Number five, lack of unified environment. A lack of a unified environment and solution that supports workloads across multiple environments, creating multiple workflow experiences, which also strain the traditional operator support capabilities. And then last but not the least, the evolving network standards. Implementing standard-based orchestration for private LTE and 5G networks has become a moving target, and oftentimes it requires extensive coupling across entire O&M stacks. Many of the legacy systems are not only partially standards compliant to 3GPP or HC or TM Forum. And so when you have a situation like this, it's in some ways fairly clear as to what are the classic requirements for a solution and platform that would drive the next generation of infrastructure. So you clearly need a platform that drives rapid migration of these systems if you choose to consolidate and its deployment. It needs to be able to provide interface abstraction at the service and orchestration layers. It has to have predefined service templates to accelerate the service deployment and model services. Most importantly, it has to have a no-code approach with service wizards, something that is truly innovative because almost any change request in today's environment for most operators requires coding, which means higher OpEx, more people, more time. It has to be able to seamlessly operate across any public, private, or hybrid cloud. And again, as I said earlier, to enable and have DevOps, which means building a modern CI/CD/CD pipeline. So once you put all these things together, that's when you get to an ideal solution to be able to drive this digital transformation. And that solution is Unity Cloud Operations. And let's take a look at that. So a firm's Unity Cloud Operations solution is built from the ground up and not as a forklift of any legacy platform. A firm's Unity Cloud Ops is a full stack telecom cloud O&M offering composed of solutions providing automation, management, and observability, which enables radically simplified operations of any G network functions to accelerate the customer, in this case, telecommunication service providers all over the world, to next generation of infrastructure deployment and migration. It provides a common user experience across any combination of public, private, or hybrid cloud infrastructure. And combined with support for both 3GPP, IFA MANO, and SA5 O&M networking standards, it creates solution flexibility for a best-of-breed architecture without a vendor lock-in. It leverages big data analytics and business intelligence. It provides performance, fault, and trace visibility to the mobile core domain, which, when coupled with orchestration, drives a number of intelligent automation outcomes. It features a comprehensive set of CI/CD/CD capabilities. It enables DevOps approach to drive the rapid monetization of new services and dynamic service changes, providing the framework for sustainable digital ops. So let's take a deeper look at the solution. We'll start top down with the monetization layer. which is the application catalog for this solution. The application catalog is the library of applications that can be deployed out of the box. The catalog contains dozens of out-of-the-box applications, and what you see here in this diagram are three of the most popular: 5G monetization, mono functions, and slice management. Slice management is our NSSMF, the network slice subnet management function, and also provides the NFMF functionality. It offers key components required to deploy slices across the mobile core domain, and as per customer requirements can interface or evolve to NSMF, the network slice management function, or CSMF, the communication service management function. These are the upper layer components, and being vendor agnostic, the solution can build a slice across the Affirm function of the mobile core or across any other third party. And this applies to slice management for 5G as well. It understands the responsibilities of each function in the 5G mobile core. What configuration needs to go on the AMF? What configuration needs to go on the UPF? Does the UPF have enough capacity? Do we need to spin up a new UPF? All of these things are integrated into that slice management capability. A typical comprehensive slice management functionality, especially for 5G and edge computing, has to understand and manage four things: slice creation, the tasks that are required to create a slice; slice monitoring, to constantly observe the slice and understand whether it's operating inside or outside of the defined boundaries. Number three, the slice modification, where you may have to change a slice, whether dynamically or based on an ad hoc request, or to have it better perform or fix an underperformance. And the fourth is the ability to participate in standard-based hierarchical slice management ecosystem. So these four functionalities combined create a very compelling slice management solution. Similar to slice management for 5G, mono functions are also very much demanded application. It offers NFVO and VNFM capabilities as a standard-based orchestration and management of virtual network functions. The layer below that is the automation layer. Automation is implementing intelligent domain orchestration through the use of service models, service templates, and workflows to deliver a use case-based outcome. The service design capability offers a no-code approach, which is one of the foundational innovative approaches that you will see and we will cover in the use cases that will follow. It is a GUI-based wizard-driven user interface, and it's driven with an experience that allows to create designs that are deployed whenever there is code requirement. And so this no-code approach does a number of things. It eliminates the extra coding. It eliminates the additional cost to change requests. It saves on people costs, and most importantly, drives down the OpEx. It also manages standard-based north and southbound integration with a closed-loop automation to execute design and production. Artifact management is also our process of delivering updates, improvements, and enhancements to automation over time. Our ability to apply lessons learned and deliver them directly to the customer. So in the world of 5G, your service model is an artifact, your service template is an artifact, your workflows are artifacts, and you might have software images, and those could be artifacts as well. And so an exceptionally flexible approach which allows, and it's almost a requirement for any 5G or edge use cases. And we can produce these artifacts for our customers to use without any effort or requirement, but it also allows our customers to produce their own artifacts, and all of these artifacts can be supported in their local repositories. Things that are captured in domain orchestration are standard-based northbound and southbound interfaces. Depending on the operator, it can integrate into a hierarchical service orchestrator above, or it could integrate to a vendor proprietary domain-based manager below. The domain orchestrator is effectively the execution engine. It's what's running all the design artifacts that have been loaded into it. The next layer down is the management functionality. The role of management in this context is to handle all the initial tasks that are required to deploy a number of functions to the point where it's reachable. And that might involve grabbing software images, pushing software images into Kubernetes, installing certain policies into Kubernetes to manage the containers or pods, deploying the actual federation and all of the dependencies that are required between the pods so they can better communicate. One can call that a service mesh, and it is stitching. It is all the stitching that is required to complete the first step in deploying an NEG Unity Cloud-like platform. Lifecycle management, we are using as a broad term here. It encompasses many different products. But in essence, what all of those do is handling the instantiation of virtual machines, virtual functions, and cloud-based functions. And if you're in an OpenStack environment, it means turning up a virtual machine. If you're in a Kubernetes environment, it might be holding a pod. If you're in a Unity Cloud environment, it might mean deploying a number of pods, say N pods, so that the microservices can function properly. But ultimately, it's the lifecycle manager that has the southbound interfaces to the VNFs and CNFs, and typically a northbound interface to some layer of orchestration, depending on how it has been layered within an operator. This role has to be very standards oriented. It has to follow a MANO environment for its execution, 5G environment, and the 3GPP standards associated with that. In some cases, there are vendor proprietary standards, but this can also be a proxy between standard compliant and non-standard compliant execution. What's deployed at the network, where it's deployed, how many things are deployed, it understands the unique dependencies of the 5G and the cloud. And we will also cover this with a few examples in the upcoming use cases. The next layer down is the observability solution. The need for observability in 5G networks and for mobile edge computing are unique in many ways. It needs to be real-time or near real-time to look at the data and drive management and automation. Unity Cloud Ops' innovative approach uses a firm's virtual probe capabilities and heuristics to provide trace management, manage events, map it to the specific set of metrics in a very, very lightweight manner. It's tuned to the requirements of virtual and cloud network functions. Based on the requirements of the operator, it can integrate into existing assurance functions and provide and extract data as needed. The level below that is the cloud management and optimization tools. The primary function of the cloud management and optimization layer, as you see there, is to handle seamlessly, but in a very stable way, the movement between any of the underlying cloud platforms, whether it's public, whether it's private, or whether it's hybrid. This is where the OPM functionality of a Unity Cloud solution would live. It will handle cluster lifecycle management, especially in scenarios where it's a cluster as a service, such as the case of Azure, and it uses automation artifacts for the cloud and also hosts the PaaS dependencies as necessary. These things decide essentially the relationships between our functions that create the federation and the kind of stitching that goes on in terms of number of pods to number of microservices. The PaaS dependencies live here as well, and when a service has certain other requirements, this layer ensures that all the prerequisite components are already existing and are properly deployed and already scaled to be able to reachable when the things get layering on top of it. This is also where we typically automate assurance or inventory. So no longer do you have to add a device to your event system or add a device to your performance system after you turn it up. The process of turning it up is inclusive to those into these observability platforms tied into the cloud platform. Next is analytics and business intelligence. As many of you know, 3GPP has published NWDAF specifications and approach to standardized method of implementing analytics on a 5G network using predefined functional roles, some predefined use cases, and obviously predefined data structures. Currently, a lot of use cases are focused on congestion and slice function, for example. Unity Cloud Ops takes a flexible approach based on operator requirements and use cases, leveraging first and third-party DAF and NWDAF solutions. Unity Cloud also interoperates with environment outside of the DAF specs based on any existing BI or analytic platforms that may exist within an operator. And lastly, to put it all together, is the DevOps and the CI/CD/CT approach. It is last but not the least, because in many ways, all of these solutions don't mean much if you're not able to deploy it in a DevOps model using the CI/CD pipeline that is optimized for automation and used by our customers, as you will see in the use cases. For all of our customers to benefit from this, we have created a lab where our customers and partners can engage to test, validate DevOps capabilities, and see our CI/CD pipeline in action. Please reach out to us via the Affirmed website to learn more, or through your account executives if you want to engage with us in that lab. So with that quick overview, let's take a look at some use cases for telecommunication operators who are using Unity Cloud Ops to drive digital transformation and to deploy 5G edge and the cloud infrastructure. So we're going to look at 4 different use cases. 3 of the operators are in the European EMEA region. One of the operator is one of the biggest tier 1 operators in North America. Each of them is looking to deploy, is already well underway, deploying a 5G infrastructure and a multi-access edge compute platforms using cloud. And each of them face the unique challenges associated with deploying this next generation infrastructure, given their scale and size and given their ambition. So let's start with the first 2. Both of them are in the EMEA region. Both are tier 1 operators and market leaders in their home countries. Both have a very strong mobile and broadband customer base, totaling between 10 to 30 million subscribers respectively. Both are primed for transition to 5G and are actively looking to deploy multi-access edge computing. Both face major challenges in creating a platform that would allow them to be the foundation for automation and digital operation. And specifically, there were a number of challenges they were facing from a network perspective to optimally expand their network coverage, to create very specific network slices for the enterprise market, managing the orchestration automation and the entire capability that was required to deploy a truly multi-access edge compute platform was a big gap for both of them. OpEx was a huge concern because all the manual processes that were involved in getting legacy systems to deal with a 5G or a mobile cloud edge kind of an environment. They were facing a lot of barriers as a result of the siloed legacy systems that they had in place. And they were really struggling with lack of automation tools, which did not give them the visibility. And obviously, all of this impacted the overall customer experience that they were looking to deliver with 5G and multi-access edge computing for the enterprise market. So they selected Unity Cloud Operations as the platform. And in the first case, the focus was on 3 key areas. First was service agility and automation. It was taking them too long to define, create, test, and deploy a service. The existing solutions, as I mentioned, were too labor intensive, required custom coding, and it took typically several months to really define a service for the enterprise or even for the consumer market and deploy it. And they were looking for something truly unconventional, an innovative approach that could dramatically increase their service agility and essentially create the foundation of a greater automation platform to drive the deployment of their extensive 5G deployment as it was planned and the next generation of edge for enterprise networks. What they specifically chose, as you can see on this slide, is the domain orchestration, the service design, the lifecycle management, the slice management, and the multi-edge computing solution from our firm. What was the compelling functionality that separated Unity Cloud Ops was the no-code approach, the GUI-driven service and workflow modeling combined with Unity Cloud Ops, CI/CD, and DevOps that brought down the time for new service creation and deployment down to several weeks instead of several months. And it dramatically reduced the OpEx and eliminated the need for custom coding every time they had to make a change or every time they were looking to design a new service and deploy it. In second case, the challenge was similar, but with a different approach. The challenge was too many legacy systems and a lack of a unified environment and a solution to support workloads across multiple environments that created lots of workflows experiences which were a strain on the traditional operator support capabilities. So what they were looking for was a single stack solution, an end-to-end NFVI service orchestration and automation platform that would radically simplify service creation and provisioning, reduce the activation cycles by using an integrated activation across all domains. So in their case, it was a combination of all 4 layers. The application catalog and using specific requirements, in this case for Wi-Fi management and IoT, on the automation layer and management and observability layer, taking key pieces of service design and service activation, handling the lifecycle management, and driving and providing the observability to drive the level of automation that they were seeking. Both of them used quite extensively the DevOps approach, using our CI/CD specifically for the automation part. And some of that you will see in our lab for those who want to engage with us and actually see it tested, see it being used both in terms of real life use cases in the lab environment. The next two use cases are focused primarily on 5G. These two are in many ways, two ends of the spectrum. The third use case is an operator in North America, tier one operator, well over 30 or 50 million subscribers, and at a scale at which they were operating, the biggest challenge they faced was the lack of insight because of poor management of data. And so what they were looking to do was to export and consume data, insights and analytics in a way that made sense for their business, to support and manage the core network deployment and achieve the underlying assurance for it using this data, and using the existing orchestration and automation, which was not meeting the requirements of 5G, to be able to wean off that and move towards the next generation platform, which is Unity Cloud Ops, for their 5G deployment. The fourth use case is an operator in Europe with one of the largest consumption of individual bandwidth anywhere in the world. And it was a coexisting environment with 4G LTE and moving to 5G and slowly shutting down 4G LTE as the acceleration towards 5G started aggressively in 2020. And so they were looking for, again, a single stack solution, cross-domain, end-to-end. And the choices they faced were interesting, which is where to use legacy systems or which functionality to use within legacy systems and which functionality to bring in as part of Unity Cloud Ops. And so as we look at both of them and the choices they made around the use of Unity Cloud Ops, in the first case, the large tier one operator in North America, its initial deployment overcoming these major hurdles around lack of data discovery, lack of data transformation, being able to export data, being able to consume data for the business. The lack of exposure to interfaces and the inability of existing systems to provide on-demand data at all the key touch points, and especially at the critical user plane level, was a major roadblock to deploying and optimizing 5G and cloud-native solutions. But with Unity Cloud Ops, and especially the observability layer that you see on the slide here, they were able to bring down the OpEx cost and were able to accelerate time to market because they were able to pull, using the observability solution, they were able to access, collect, abstract, and expose all the critical operational network and assurance information related to performance and quality of 5G network as a service. And working seamlessly with the existing Affirmed Unity Cloud platform, they were able to accelerate the deployment of 5G network rollout, deployment of new services, specifically at the edge for events, for enterprises, and to deliver great customer experience in real time, specifically for rich media events. And so this was a very successful deployment, keeping in mind that the first hurdle to clear was really managing and optimizing data at the key touch points around the performance of a 5G network, around the deployment of the 5G network, and around the assurance of the services that are delivered over that 5G network. In case of the last operator, the one we talked about in Europe, for them, it was an interesting choice, what to retire among the legacy systems and what to use within the Unity Cloud Ops to be able to accelerate the 5G deployment. And let's take one example, just as an illustration of it. They had an existing legacy inventory systems, which it was a existing legacy inventory system, which didn't inherently understand the composition of 5G services. So, for example, if a legacy system were to run a discovery against one of our Kubernetes clusters, it could find most likely all the individual pods, but it really won't understand the relationship between those pods, especially when deployed as a federation. So one microservice is a federation of pods, and there might be 10, 12, 15 pods that work together to deliver one federation function. So for example, an AMF, the 5G network, is 12 pods. And when our active inventory systems tracks these types of functions, we understand how the pods are working together, and we present them in the context of their federation or microservices function. So what you know is that these 12 pods are actually one AMF. A legacy system cannot understand that it's one AMF. They could potentially display the 12 pods, but that's almost useless, given that you need to understand the context and the composition of a service and how to manage it through your service mesh. So the operator was able to make smart decisions using Unity Cloud Ops as to what legacy systems to retire, what legacy systems to be used to extract the appropriate information, and then combined with Unity Cloud Operations to start deploying 5G aggressively across its market. So with these quick overview of these 4 use cases, we were able to get a sense of how 4 different operators in 4 different parts of the world, all of them driving towards digital transformation, rolling out extensive 5G networks, rolling out a very smart multi-access edge solutions for the enterprises, are able to use Unity Cloud's various functionality to drive the kind of business outcomes that they were looking for. So based on these use cases and the number of years of working with operators around orchestration, automation, and management, and solving the problems around moving to digital transformation and deployment of next generation networks, what are some of the key takeaways that we have learned? Number 1, the no-code approach. It's true innovation, it's compelling, it significantly reduces time to deployment of new or modified service offerings using a GUI-based service model design combined with data wizards and intelligent workflows. It's one of the most powerful value that we can provide to operators in terms of reducing their costs, reducing the amount of people they have to use to manage and deploy new services. Number 2, integrated analytics and BI is critical. Traditional closed-loop assurance combined with event, metric, trace, and probe capabilities drive a lot of advanced data analytic functions to provide zero-touch visibility for the mobile core. Number 3, monetization is critically important. Automation without monetization actually only takes care of the cost part but doesn't drive the revenue. And so combining that monetization layer with automation really delivers that double tap, the double whammy, the double benefit of not only reducing your OpEx through automation, but also accelerating the revenue cycles for pretty much any of the offering that you would deploy on Unity Cloud Operations. So application libraries, the marketplace offering focused on 5G activation and slicing services enable rapid rollout of new services, rapid rollout of 5G service profiles to quickly monetize these use cases. Number 4, taking a very lightweight distributed architecture approach allows operators to use Unity Cloud Ops to deploy application and services at locations where it makes best sense for the business. Best sense for the business case, best sense from an architecture perspective. So the solution is optimized primarily for the edge and those operators looking to really empower the edge to drive innovative offerings to the enterprise. Number 5, our standard-based slice domain essentially ensures end-to-end integration using SA5-based interfaces running across a combination of public, private, and hybrid cloud infrastructure for the operators to really get the benefit of the solution that is being built for the cloud, that is seamlessly integrated into our cloud-native Unity Cloud platform, and brings you all the benefits that you're looking for, no matter what the environment, in driving that automation towards digital operations. And so what did we learn? The 3 things that we covered in this presentation: the role of orchestration and automation, DevOps and BI in digital transformation. We looked at some examples of tier 1 operators and their implementation of orchestration management and automation to drive the kind of business outcomes that they were looking for, and how they are leveraging a firm's Unity Cloud Ops solution to evolve themselves from telecommunication service providers to becoming the digital service providers of tomorrow. To learn more about the use cases that we covered and to get more details on the Unity Cloud operations, please go to our website at affirmnetworks.com, as well as you can reach out to your account teams for more information on how to participate in our DevOps CI/CD/CT lab. And we quite look forward to hearing from you, to getting your feedback, and to engage with you over the coming days and weeks. Thank you.